if I'm looking to improve my brain health and prevent dementia,
Sure.
and I want to slow the aging of my brain, essentially, what should I know about my genes and health in general, if that's my goal?
Cool. I think this is a good time to talk about ApoE.
Yeah.
So ApoE is, I think it's over 20 years now, it's been associated with dementia risk. So it's a protein, like all the APOs, is associated with lipid metabolism. They think, again, the mechanism of how it may cause dementia, and particularly APO epsilon E, which is the variant that causes dementia. They're not sure how it exactly causes it, but they think it's involved with lipid metabolism in the brain, neuroinflammation, and impacts the way the glial cells. So the brain has neurons which have the connections, and the glial cells are, well, there's in the old days supportive cells, but that had many functions in regulating the function of neurons, the establishment of synapses, memory, everything else within the brain. And the function of the glial cells. So what we've seen with people with two versions of the epsilon 4 variants, which is based on a couple of single nucleotide polymorphisms, have a very high increase in the risk of dementia. Now, there's been a recent paper in Nature Medicine that has shown that people with both copies of the epsilon E will have all have some hallmark of dementia. And when I say hallmark, a biological hallmark, you get the buildup of proteins in the neurons that then leads to these neurons dying, which leads to the dementia and the cognitive, the loss of cognitive function.
So everyone with these.
So everyone with these two variants will have the biological hallmarks, and I'm being very specific here, the biological hallmarks of dementia. So what do you mean by biological hallmarks? Well,
any age, sorry?
I think we're looking at 60, and then
60, okay.
sorry, 50. Sorry,
50.
do apologize.
Okay.
We're looking at, and then I think 65 in the paper.
Okay.
Now, biological hallmarks are saying, well, actually, you've got some of the pathology in your brain, but then when you do tests, the classical tests and the clock tests, and look at brain scans, not all of these were presenting in the clinic yet, which is, I think, is a very interesting point. And what you see with dementia is if you have cognitive reserve, you can actually mitigate the presentation of the disease. So what does cognitive reserve mean? Well, actually, it's the ability to have cells dying in your brain, but still have enough neuronal capacity. So this could be numbers of neurons, but also the synaptic connections within the neurons to actually still be able to function as a human, whilst some of those cells may be suboptimal because they've got the protein buildup within the neurons, which is indicative of dementia. Now, how do you build cognitive reserve, I guess, is the great question.
Yeah, well, that was literally my question there.
So at the moment, exercise is the great one. Cardiovascular and I think weight training is a really important one. The DASH, which is the one associated with blood pressure, and the Mediterranean diets are really important. Omega-3, there's supplements that are being bandied around with, such as ginkgo as well. Now, again, I think they're the things you go for if you've got money burning a hole in your pocket and you want to buy those things. I wouldn't say it's the first port of call, but actually social interaction, friendship networks, just education, lifelong education. These really seem important. There's interesting, and we have a bit of internal debate at Fitness Genes here. There's interesting conversations around alcohol, and during alcohol as well, of course, but about alcohol. So that you see in a couple of the biobank studies, and you see this with other conditions, but particularly with dementia, where you moderate alcohol intake is more protective than not taking alcohol. So on a cellular level, that makes no sense.
Yeah.
And there's two ways of describing this. Now, the teetotals of Fitness Genes team go, oh, it's because people who are teetotals very often have had bad lifestyles, and therefore it's a presentation of that bad lifestyle. They're just coming up in the data as teetotals. Now, where we are, but of course you can factor that into your analysis. I think where the drinkers of the team are coming from, and I think there's a lot of the data who started to go this way as well, that a few drinks, and we're not talking going to Marbella and killing yourself. A few drinks can help you relax. It would de-stress you, but actually it's sometimes an instigator of social interaction. So if you're going for a few drinks on a Friday and having a group of friends that you see, you have similar hobbies to, you meet them, you keep those friendships throughout life, that is incredibly important. There's also studies, and again,
so in a way it's more of a marker of social connection and conviviality rather than a marker of the alcohol somehow having a protective effect.
I would not suggest that alcohol is neuroprotective. You should march me out of the room. There's always been that. I think the Daily Mail will reel out wine protects you, and then next week wine is killing you. And again, I think it's because it is not the act of drinking, it's the act of the socialization around the drinking. And there's interesting other studies as well. There's the one which I only skimmed through, but being religious it can increase your life expectancy by 4 years. Now, I'm not here claiming God exists. My friends will tell you that that's definitely not where I'm coming from. But actually, in terms of, if you think about religion offers community, offers community into later in life. It offers you hobbies, and think about go down the old C of E route where you've got your women's institute, you've got all these going into church, flower arranging those. You've got all these social interactions that sit around the church that actually, if you don't have that sort of religious sort of central point and location to go to, you may just be sitting in your house by yourself. So in terms of, I appreciate this is a nutrition podcast, I would put exercise and social interaction first.
Absolutely.
And but the nutrition, of course, underpins that. And again, with that, people who are carries ApoE, blood pressure and diabetes are huge drivers. So for example, if you're an ApoE carrier and also have diabetes, that's again really going to drive you the impact of that allele, and probably going to lead you more likely to present in the clinic as opposed to just being a biological hallmark.
Totally.
So again, you can start to think about the DASH diets and the Mediterranean diets that actually underpin mitigating those risks. So instead of going, and I think it's always nice to think that there's going to be, okay, well, I've got this risk, I need to take this pot of things or eat this vegetable. And it's not the case. You've got to build those lifestyle diets that are going to mitigate those long-term risks. Those long-term risks are going to be your broad high blood pressure, high cholesterol, diabetes, and then the lack of exercise and the lack of social interaction that kind of fills around that space.
I mean, I obviously have my bias towards nutrition, but it's very hard to deny obviously the impact of other lifestyle factors. And just an anecdote, my wife's grandmother, who's soon going to be a great grandmother if she can survive until our son, our child, is born later on this year.
Congratulations.
Cheers. She's 105.
Wow.
And she grew up in Italy, so she's a nonna. She was a midwife. She lived through the Spanish flu, or whatever we call it now. Moved to Australia. Has had like a really fulfilling life. Lives in a nursing home at the moment, but has strong faith. She sees both her son and daughter multiple times a week. We speak to her every single week. She's sharp as anything. Like, she remembers everything. Like stuff that I've told her the week before, she'll pick up on. She's always cracking jokes. And her diet is terrible. Her diet is it's mainly cheese at this point, And she's been a big cheese and pasta lover and stuff. So I mean, I'm not denying that she would have had some vegetables in her lifetime, but it's definitely not the thing that I can point to that has led her to lead such a brain healthy life, and the fact that she's so sharp right now. So there's definitely something going on there.
You touched on another point, which was the location of children. Now, we live in a world, meritocratic world, where we're told social mobility is key. Go to your university, go work in London. And what you're doing is families. So I've got 2 kids. We're lucky enough that my family are from the Midlands and we live in Oxfordshire. So it's only an hour and 20 minutes drive. But there's a lot of families that are separated. There's other studies that show that proximity of children and grandchildren to to the individual has a big health effect
There you go.
as well. So it's really there is a lot of evidence around this social structure, social interaction space that's really important for the dementia sort of mitigation.
Yeah, I want to talk a bit more about the ApoE alleles. I understand that these have an impact on lipids, inflammation, and glial cells.
Yes.
Do we know anything about the other alleles, i.e., the ones other than ApoE4 that we test for?
So they function in the same way. I think the epsilon E, they believe, just raises the neuroinflammatory processes within the cells. So I don't think there's a gain of function in any way that this is going around doing something terribly bad in the cell. I think they just it is impacting one of those processes. Now in essence we just don't know. We just don't know the mechanism for it. We just know what the protein does in the cell. We know the variant that's associated with the disease. It's researchers will be working on at the moment to understand exactly how it's impacting and how it's raising the risk factor, but it'll be associated probably with the buildup of protein aggregates in the cell potentially. But that's only based on the latest hypothesis within dementia. They've gone through a few phases where people didn't believe the protein aggregation theory of dementia at all. So we're always open to new ideas, and of course, it's not the only driver of dementia as well. It will be, I'm guessing, modifying other pathways that are naturally progressing in neurons as they age as well. So it's not just that is the only driver of that dementia in ApoE carriers. There'll be other things going on. There'll be the energetics of the neurons are long-lived, as in they're not replaced very often. They're highly demanding in terms of energetics. So there are lots of different things that are going on in the cell, and understanding the interplay with this change in lipid metabolism, how does that accentuate the pathology of aggregate buildup, and then how does then that lead to the degeneration of the neuron? We're not quite sure yet.
Just a quick one. If you're enjoying this content, you will love my mini series on inflammation. I go through the different types of foods that you should be having, what inflammation actually is, plus lifestyle practices to reduce inflammation. You can get it for free right now in the link in the caption below. Back to the podcast. So with ApoE4 and these alleles, I've heard that there might be some sort of evolutionary benefit for folks that, I'll say that one more time, sorry, Mitch. With ApoE4, is there any suggestion that these genes would have been helpful for us during our past, like when we were fighting off pathogens and privy to infections in sub-Saharan Africa?
Sure, yeah. And I guess this boils very much down to, do you believe in the gene-centric view of evolution? And actually, are we just epiphenomenon to pass on our genes, as Richard Dawkins can say? And there's definitely credibility to this thought process. So we are talking about genes that cause disease later in life a lot of the time. But actually, just because you have ApoE4, is that just a highly negative thing? Well, I can understand why people think it's negative, but actually it may exist within the population because it has conferred advantages in the past. So there's some evidence to suggest it increases fertility. Now, if you think about it in terms of evolution, we're here, we sit on the planet, we procreate, and then we've passed on our genes, that well, job done sort of thing. And there's a second point that there's, I think, some evidence that show that actually may be protective against childhood diarrhea. So again, if you think about, in the days of new antibiotics, of low stage care for children and high child mortality, these are really big advantages. So again, we go back to the conversation of biological trade-offs, where actually the presence of the epsilon 4 variants is highly beneficial early in life. And we are starting to see this again and again with variants that are associated with disease, where they confer the benefit in early life, where actually there is a very good reason to be supporting growth, survival, immunity, development, reproduction. And then actually the genes carry on kind of doing what they're doing later in life, and as the variant which is associated with potential neuroinflammation in the brain, which causes dementia, that may be having some impact in another tissue because it's expressed more broadly, that actually confers a very positive effect. And I guess it boils down to something what we call the selection shadow. Is once you've passed on your genes, actually there's no real selection impacting, because there's certain genes that actually we could turn off later in life. For example, we think about IGF-1 and growth hormone. When you're growing, they're really important. So what you see is with increased expression or variants associated with high levels of IGF-1, they're very beneficial early in life. You grow stronger, you're more likely to survive. But actually later in life, they're high IGF levels is linked to many diseases, including cancer, diabetes, and everything else. So in reality, biology doesn't really care about us later in life. It just wants us to, go big, grow big, procreate, and then go home, metaphorically speaking. So, and I think this is a fascinating component of evolutionary biology. I really enjoy evolutionary biology, but it really has a big impact on how we think about health biology as well. And it goes back to this destigmatization of having disease alleles, and we are all big mixtures of different variants that confer advantages and disadvantages. Other examples are we started in the muscle building field that angiotensin, the mutations in the angiotensin converting enzyme raises blood pressure, but it is really important early life for cardiovascular fitness. So if you want to be an athlete, which is an amazing thing to achieve in your life, which we can give you great acclaim and great love and what could be truly a great life. Later in life is going to give you high blood pressure. It's and you can see this with a lot of genetics. It giveth with one hand, it taketh with the other.
Yeah, it's just a series of different trade-offs. This might be a bit of a left field question, but are you aware of any evidence or data to suggest that in spite of someone's genetics like ApoE4, for example, and being a double carrier, if you were to engage in the activities that you described as potentially increasing one's cognitive reserve, exercise, Mediterranean-style diet, omega-3, social interactions, that you can lead essentially a disease-free life?
So in the paper where it showed that if you have two versions of the epsilon-4 variant, every single person had a biological hallmark.
Sure.
Not every person presented with brain scans which were indicative of having dementia.
Okay.
So what you're seeing here is you can have a biological burden, but you may not present with a disease. And I think this is very key now in terms of there was no longitudinal data of the individuals in that paper because, of course, they're done from autopsy samples. But there is evidence, I'm sure, that suggests that, and again, we talked about cognitive reserve, if you're maintaining your lifestyle to be as healthy as possible, you can at least reduce the risk. Now, whether you can live that long, healthy life is you just think about politics. You can't predict the next 5 minutes, can you? And I think with biology, you're not going to be able to predict 20, 30 years in advance. But if I was sitting here today with those two variants, if I was homozygous for the epsilon E variants, I would strongly consider everything we've discussed: the diet, the exercise, the social interaction, the prolonged education, the limitation of alcohol. So obviously that 2 pints in your social group on a Friday. I think that's really important. So there is cause, and I think it's quite an exciting stage where we're starting to understand this disease, because as well there's lots of research going on into compounds that can reduce the cognitive decline, that can reduce the death of the cells, maybe promote autophagy to then get rid of the tau, the amyloid in the brain, which forms these clumps, which leads to the death of the neurons. So again, it's not just about, okay, well, think about myself in 10, 20, 30, 40 years time.
Sure.
It's actually how much can I kick the can before the drug discovery pipeline catches up with it as well. So you're kind of in that sort of it's not a 2-horse race, but you've got these two processes that are going on that can help you survive and live as long and healthy as possible.
Yeah, just stick around long enough for the science to hopefully kick in and ride that wave of new drugs. Yeah. Let's talk about cancer. Cool. Again, similar question in terms of genes. What should I know about my genes if I'm in the business of trying to prevent cancer as best possible?
Cancer, there's a lot of heritability in cancer. There are certain people that have, again, single mutations that lead to cancers, but they'll be very much early on childhood cancers. Again, there'll be, in terms of the polygenetic sort of area, there are lots of variants that increase your risk of cancer. But cancer in itself is a very complex disease, and the nature of cancer is you will get what you call somatic mutations. So within the cells, you'll get mutations occur. So the where disease genomics is going with cancer is actually to sequence the tumors, because the tumors will have their own genetic makeup, which is actually will be potentially different from, say, my genetic makeup today. So you may have the repression or the deletion of tumor suppressor genes. You'll maybe have lots of different proteins that are associated with cell division that are regulating. You can actually have it where you duplicate proteins associated with cell division. Okay. There's certain changes in the cell which change the metabolism, so it's called the Warburg effect, where it's aerobic glycolysis, where they use energy in a different way. So where genetics is going in terms of cancer is you would sequence the tumor, you'd understand the genetic nature of that tumor, and then you can start to target specific drugs. Because again, people think about cancer as one disease, but it's many, many diseases. With, prostate cancer is very different to breast, to brain tumor. They have different genetic liabilities within them, as well as stochastic liabilities that have happened due to the nature of cancer. It's understanding those specific genetic signatures in the tumor that then will enable us to target chemotherapies or particular drug immunotherapies, which are, a lot of is being made of at the moment. Sure. So in the space fitness genes are in, we don't do the cancer space. We could say you have increased or decreased risk of certain cancers, which has some merit. But I don't think, the one thing we want to do at Fitness Genes is be able to give you direct advice to mitigate the risks we're describing. Gotcha. And with the cancers, because you have a slightly increased risk of cancer, but generally everything we do at Fitness Genes is towards mitigating the risk to a certain extent. But we cannot give specific advice on different cancers because of the nature of cancer in itself. In the grand scale, I totally get that point, and I guess the question was probably a bit tongue in cheek, because cancer is very much an umbrella term, and there's so many differences, as you've eloquently described. In terms of the number of potential mutations, again, sort of ballpark figure of all the different SNPs that we are aware of that would push someone's risk profile to higher risk of all different types of cancers. Let's just talk about the big ones: breast, prostate cancer, lung cancer. Do you have an idea of the number of SNPs that could be for those as well? There's sort of moving towards the monogenic forms, which is called, where you've got single genes. There's kind of the classically described ones associated with breast and cervical, which is BRCA1, BRCA2. But again, I think that the risk associated with that is around 15%. Yeah. But again, it's polygenic. So in terms of how many variants are associated or linked with changes in risk of cancers, we're talking thousands, 10,000s. And then you'll have your different specific cancers that will have their different subgroups of those variants that are associated with. Some will be more broad. So there's the tumor suppressors and the proteins associated with cell division that you'll find mutations that increase the risks in many proteins. And then there are other genes that will be associated with, like the BRCA1, BRCA2, which are associated with particular types of cancer. So you have very rare mutations which can create tumors very early on, and you'll see that in childhood cancers very specifically, because the rare mutation totally changes the way cell division occurs, and you get very, very aggressive tumors. And then there's kind of the cancers more derived around lifestyle, where when you're smoking and drinking and eating poor food and not working out, that then will increase your risk of the cell cycle, which drives the division process going awry, and then creating different types of tumors.
I'm just wondering if there is a world, and I'm not too sure whether I'm in agreement with this, but if I chose to take up smoking, for example, I could, broadly speaking, figure out whether I'm going to be in that category. Everyone's had that anecdote of, I know someone in my family who smoked for like 60 years and they never got cancer and they were fit and healthy until they died of something completely unrelated, or the camp where I would die after a decade of smoking related to a cancer associated with smoking. I wonder if there is a world in which we can actually risk profile someone who comes into the clinic and is an active smoker, and I can pull up their genes and say, your genes are not great for a smoker. You're not going to be one of those people that survives into their 80s and 90s smoking the way you're doing right now. So do you know what I mean? It gives even more impetus to someone to actually make that change and give them the motivation.
So yes, I think it's kind of like you're going to run across a motorway which has 5 lanes or 100 lanes. It's kind of thing. So you absolutely can see, and this is where polygenetic risk scores very much come into their own, is you can very much identify people that are very high at risk. And there's quite a few studies that have shown that these are the people that are most amenable to lifestyle change. Now, if you think about any disease where you're in the highest risk category, it doesn't mean that's where all the disease sits in those individuals. Of course, through lifestyle, something like cancer, even if you're not a BRCA carrier or not in that highest risk category group, other people within the population are still going to get that breast cancer. But for those individuals in that high risk group, these people seem to be, these are the people we should be sort of suggesting particular lifestyle interventions for. Just to go back again on the prediction, I think the predicting thing's very interesting. And the one thing we're seeing now in terms of predicting things very far in advance is the constant reevaluation. So something called health trajectories. So the one thing we do at Fitness News is we continually collect data. We actually update our polygenetic risk scores when new information comes in. So it's the predictive capabilities. Okay, well, we know you're increased risk, but there's no way in a million years where you touched on at the beginning would go, well, actually, you're 100% fine, because you just do not know the complexity of that system. There are many genetic variants we've not discovered yet that will be causing disease. We've talked about that there will be, many people have what you call rare variants. So we can just be in you or a few family members which cause a common disease, be it diabetes, be it dementia, that actually we don't know about. So when we look at our genetic array, we're not picking these things up. So it's the health process, the evaluation, and the wellness, preventative healthcare space needs to involve constant reevaluation. It's the same with predicting anything. Predicting the weather, predicting an economy, you've got to have that continued evaluation, because there's all these additional inputs that are altering the system. An infection, for example, like COVID, look at what COVID's done to the health system. And that in itself, in terms of not just getting COVID and having the immune response of COVID, but the social isolation, we've talked about social interaction, dementia, those components that are just, you cannot predict within the system, is going to keep us on our toes for a long time in terms of scientists.
I want to talk about obesity and fat and where we store fat, and something that comes up time and time again, which is belly fat. And is there something, or are there genes or tests that we should be aware of when it comes to how we can best prevent fat, particularly visceral fat as well? That's something that I'm very interested in. And is there a sort of explanation as to why certain people keep and store excess energy in the form of fat in certain parts of their body as well? That is determined by genes in some part.
I think the storage is that there's definitely genetic variants. I can't remember which ones that are linked to increased risk of visceral fat, so fat around the organs.
Yeah.
In terms of the storage of fat, I think you're probably looking at more broader body composition sort of traits. So obviously major ones are sex, and then the hormones associated with sex, and they drive where you put fat down. Of course, height, everything else, these things will impact where the fat goes down. But the majority of the variants associated with obesity are mutations in the brain. They're associated with our response to hunger, so to satiety. So the leptin melanocortin system is the one that's regularly talked about. So we started to find mutations in leptin. So leptin's a protein that's secreted from fat cells to say we're here, we are fat cells. So it's a way of telling your body that you have adequate supply. So we're going back to the evolutionary route here. We think about ourselves in terms of the obesogenic environment, but actually the biggest risk would be not having enough fat, not being obese. So they found that these individuals, incredibly fat, had an insatiable appetite, and they kept eating. I think the anecdote was they would go to a freezer and eat raw fish fingers. And what this is doing is you can either have mutations in the secretory protein, the leptin itself, or the receptor on cells. So leptin binds to go, yes, there's fat here. So the more fat you have, the higher levels of leptin. Because the mutation is either in the protein or the receptor, the body thought it had no body fat. Even though you were obese, your body thought you had no body fat. So it was driving you down the survival, gravage yourself to death sort of pathway. There's other ones in the melanocortin system, which is associated with the signaling pathways associated with feeling full. There are certain mutations that are linked to what is called fat taste. But actually, when you eat certain food, you don't taste it in the same way of salt or sugar or anything else, but it binds to a receptor that tells your body you've ingested fat. So it's a way of going, great, we've got some fat coming into the system. So therefore, it decreases the hunger. So obesity is very much linked to these proteins that are detecting nutrition, detecting fat in the body, and detecting the passage of particular nutrients through the gut. So that's very much where a lot of the obesity genetic knowledge has pointed us in, that actually obesity is, because in the old days it's a metabolic issue. I don't burn enough fat, and there are components around uncoupling where some people can be thriftier or less thrifty. Some people need more, and I think that is true. Some people will, where the mitochondria, so the powerhouse of the cell that metabolize all our energy, they can be less efficient in converting the food energy into what is the currency in the cell, which is ATP. So that's the one that all the molecules and systems and muscles in our body use, and the brain is ATP, which is a molecule which has energy in the bonds. So when you break these little bonds, it releases the energy. We don't literally feed glucose into a muscle cell. We have to convert it to ATP first. So we've very much in the old days, we thought it was efficiencies or inefficiencies around the energy. Actually, what it seems to be, nutrient signaling, nutrient sensing, our ability to feel full. Now, the more and more you eat, and if you're obese, and this is not linked to any genetic defects, you can get something called leptin insensitivity. So actually your body stops recognizing the leptin signaling, and that then can lead obese people to finding it a lot harder to lose weight.
So this is really interesting, because it seems that there is a spectrum all the way from severe leptin resistance, where you just cannot tell whether you are satiated or not, and ergo you start eating raw fish fingers because you can't wait to cook them, And then there's the sort of grey spectrum where you can almost instill leptin resistance through the eating behaviours that are quote unquote westernized.
Yes.
Do we have a sense of just how many of us have that leptin resistance as a genetic abnormality?
So we look at mutations in the leptin system, the rare mutations now as well, and in the melanocortin system, and I think it was about 0.1%. So it's we have people on our who are members who have rare mutations, and we can look at the data and they are obese or clinically obese. Then in terms of again we go back into the polygenetic perspective on then you have there's genes, you may have heard of FTO, which was coined as the obesity gene, again linked to nutrient sensing and many other. It seems to be a regulatory region in the genome that may have many impacts. The leptin melanocortin system, so we look at many of the associations with mutations in that system, which is about do you feel full? When you've eaten, do you have those feelings of fullness? Then there's sort of the ad hoc kind of pathways associated with fat sensing, sugar sensing. So some people just don't sense when they eat it; they don't get the sort of the signals to go, "You've had your sugar now." And then you have a build up, and again, it becomes then a polygenetic score. You get all these different. You can create a great burden of all these different variants associated with slightly different components of the. You eat, you recognize it in the mouth, you digest, the gut recognizes it, that you signal to your body to let your body know you've had food. And again, it's how much do you eat during a single sitting, but also when do you initiate your next meal? And these variants can impact all those different timing points of eating. But the obesity, the one thing we find the obesity, at least in the polygenetic sense, it is hugely manifested by the obesogenic environment. Again, you think about 100 years ago, these variants were still prevalent. There was no obesity. It is, they were beneficial, I guess, in terms of it is important to, when there is food around, to eat and eat well. But in terms of whether they've been selected for in that way, I'm not quite sure, because you would expect everyone to have the obesity genes in that case, wouldn't you? Or at least the common obesity variants. So I'm not necessarily thinking these are genes that have been massively selected for. I think there's just been a diverse human population, and some people have variants that in an obesogenic environment are problematic because they feel full slower. They're more likely to eat quicker, and they don't sense the intake of certain macronutrients, which means they will then go on to eat for longer.
I guess that this is sort of like part of a wider question, which is, how much we should be caring about our genes given the impact of our environment and the impact of, other things like our microbiota. And I think there is a sense that whilst it's nice to know what your genes are and what your probabilistic risk is, does it change too much in the context of what we need to do in terms of our environment? And how much of this is having a driver versus the environment?
It depends on the traits and the person. So someone with a high genetic burden, it can give them an understanding. So in terms of, why, because if you say to someone, okay, well, it's just your obesogenic environment, and then you'll have some advice like, well, just eat to when you're full. And that's advice that's giving a lot, isn't it? But actually, if you know when you don't feel full, you could be metabolically full. That piece of information is very important. And so the genetics can actually and we found actually, because I was at the Festival of Genomics, someone came up to me and says, do you feel people get annoyed when they find out this information? Do they feel stigmatized? Well, actually, no, it basically the penny drops for them. Is because when you're feeling hungry, you feel you need to eat. It's a fundamental drive of a human being. But if you know you have these variants that increase your ability to overeat, I think ability is the wrong term, but what can drive you to overeat because you are not you are not feeling as hungry, not feeling full or as satiated quick enough, then that's a really important piece of information to give someone. So yeah, but again, of course, it only manifests. So you'll have people, and we've done studies within and looked at our cohorts where they have the burden of these genes, and then you talk to them. And the one thing we've done, we're over 11 years old now as a company. We've always talked a lot to our customers, and you have a conversation with them, and they have incredibly rigorous behaviors around food, what they eat, how they cook meals, how they eat food slowly. So actually, they have, without thinking, put in the methods of stopping weight gain by themselves. And that's very interesting for us as well, because we can use that data then to communicate. So when we do the genetic analysis, we give advice. So for some of the people who very much respond, people say, well, what foods to eat? And of course, get rid of processed food and everything else. But sometimes it's replacing that impulse with something that's enjoyable but not food. So go listen to your favorite track and go for a walk.
Yeah.
Go to see your pet dog and stroke it. Have you got a favorite book at the moment, or favorite song or TV program? Go to those things for that enjoyment, because some people as well have that. And there's another component of overeating, which is the impulsive dopamine sort of circuitry, where you're just going for that hit of enjoyable food. And that's something else that, if someone sat down and really thought about their behaviors, they could probably work it out by themselves. But when you have the tangible data behind you saying this is what it is, it becomes less opaque for them. It gives them something to push off to make the lifestyle change, because it gives them direction, it gives them an understanding.
In terms of that energy expenditure model, you've got the thermic effect of eating, you've got your non-exercise thermogenesis, and you've got your basal metabolic rate. And notwithstanding the fact that you can change that slightly by reducing calories, changing your muscle mass, is there a genetic determinant of someone's basal metabolic rate that would distinguish a thinner person from a bigger person?
There is a component, and we talked about the uncoupling, where you can be less efficient or more efficient with food. So instead of using all the energy in your foods to create ATP, you drive some of the hydrogen ions through the mitochondria, and it gets lost so brown fat is an example, actually utilizes that process quite nicely for keeping warm, because it actually generates heat. The other one so the other uncoupling processes drive different signaling processes within the cell. But generally we're talking tens of calories maybe. It's so over a lifetime it can be significant, but when we're talking 2-3 years, when people really start to put weight on, it is we trying to figure this out. I've not seen anything definitive, but in terms of response to exercise, there's a lot of work at the moment that looks at like aerobic exercise, where I think you have an initial benefit, and then basically then it trades off with so for example with running, you see that actually it reduces inflammation, which is great for health, but actually that's reducing the calorie need burden. So actually with aerobic exercise, it can, over time you burn less. So you get your Garmin says you burn 600 calories, and it's just not true. When you start off running and you're inefficient, and also if you're large, it is probably true, because you are literally putting the work in. But you build in efficiencies and trade-offs within where you reduce the calorie burdens with running. Like weight training, I think you've got to repair that muscle. So weight training is really good for maintaining or burning fat. Which seems counterintuitive to people, because you think you're getting bigger, don't you? And you've got to put a serious amount of work in to get bigger with weight training. But actually, so we're very much lean to sort of, I'd say like 60-70% weight training in kind of our flight. Again, it becomes personalized. But if you just to come up with a standard high level sort of number, 60-70%, even 75% weight training, sort of 25% aerobic sort of VO2 max. And the VO2 max, so the cardiovascular stuff, it's like an 80-20 split around like baseline to high intensity stuff.
Well, that was going to be my question actually around exercise. Do my genes determine the best form of exercise that I should be doing more of for longevity and healthy aging benefits, let's say, or metabolic benefits? So should I, as someone from South Asian background with my set of genes, should I be doing more aerobic versus weight training, for example? Can we be that sort of distinctive?
Not in the primary sense, in terms of we have a gene here, which means if you do weight training, your diabetes reduces, or if you do not in that.
Okay.
You've got to think about it in terms of like weight training is really important for muscle mass. If you've got low muscle mass, do weight training.
Sure.
Now, in terms of how you respond to those trainings, so there are sets of genes that are associated with how, for example, you respond to VO2 max training protocols. Now, that may mean if you're into running, you might, if your VO2 max training doesn't elicit the greatest results, you may want to do different things to improve your running time, be it economy running, maybe more baseline running. And it's the same with weight training. Genes will not say whether you respond better to weight training, but it may tell you whether you're not going to recover as quickly as someone else. And alpha-actinin 3 is your prime example, where it decreases your recovery time, basically. So I think generally weight training first with good cardiovascular health is the general sort of overarching advice. However, how you then respond and recover and deal with those, and what specifically do in terms of the aerobic training protocols, genetics can inform that in some way. But in terms of general health, it's quite trivial for your muscle builders who we used to work with in the past, or with particular groups of athletes. It is highly interesting. But for long-term health, it's an interesting sort of piece of information. It's not mission critical for health at all. No.
Are there any like sort of 80-20 in terms of the genes that one would sequence that would have the most bang for longevity and disease prevention benefits? I'm very interested, for example, in my supplement stack and what supplements I should be taking. I take a B complex, I take omega-3, something that we discussed earlier, even though the evidence is not obviously the best, but I'm willing to take the financial hit and the potential side effects. And I take vitamin D3 because I know that my vitamin D is crashing low with K2 as well. Are there things that are there genes that that you feel that everyone should know to have sort of the biggest impact?
So we haven't really touched on this. So there are genetic variants. So it sits within what is called pharmacogenomics. So these are the genes in your body. Many of them are expressed in the liver that metabolize the vitamins, the drugs that you put into the body. And some of them can mean you have lower levels of, say, serum vitamin D, lower levels of magnesium in certain instances, lower levels of different vitamins. So they can highlight whether you have maybe an increased need for, say, vitamin D. And I think the variants associated with vitamin D metabolism have the most evidence behind them. But in terms of broadly, I think of the way I would, so they're informative. I think they're important in conjunction with the other genetic data. But for me, I would stick with what we've been talking about, the dementia risk, the LDL risk, the diabetes risk. They're the things that really will be having an impact on your life. This, again, the way I could, before I came to this talk, I kind of factored the genes in three ways. There's the causative, so we've talked about ApoE, we've talked about hypercholesterolemia, the predictive or the probabilistic, which are the large polygenetic risk scores, and then the informative. So the informative, I'll put in caffeine metabolism, for example. Everyone likes the caffeine metabolism gene. It does have impact on heart health in a small amount. It has an impact on sports performance when you take caffeine in a small amount. And a lot of these vitamin associated variants sit within this informative. It's when you're starting to really want to, if you're healthy, if you're doing your 80-20 exercise, if you're on your Mediterranean diet, if you're feeling really good, you can start to teasing these pathways apart. If you are doing everything to cover your sort of long-term health issues. Again, this is really the optimizing biohacking crowd that will get value out of these. In terms of the general health crowd, there are other things you should be looking at.
Okay.
I hope that makes sense.
Yeah, that makes sense. Yeah. I mean, you probably sequence your genes. What are some of the insights that you've gleaned from your own data?
yeah, it kind of
and is that, sorry, just for folks listening at home, is this something you do once in your lifetime?
Yeah. So the
it stands to reason, but
no. So we do one genetic test. Now we can do genetic tests in the future as we can be more comprehensive in terms of what regions of the genome we look at. But at the moment, you do it once. There's one payment. This is something we're quite tight at Fitness Genes at the moment, that we don't want to tie people's health data to subscription models. I think that's really important. Now, of course, our shareholders love that, or not, as the case may be. But actually, I think in terms of when you're building a health tool, there is a value to be created across the health ecosystem. So we can talk about we've talked about it before, supplements companies, that actually there are ways of finding the right consumers that have the right needs in terms of, we've talked about with ApoE, with certain types of diet, certain type of exercise, but also community groups. There's actually a way I think the health ecosystem can start to really build advantageous products and services for preventative healthcare. So yeah, we do it once, but we really see actually the benefit of this. And as we talked about with longitudinal data and continually predicting the model, people will continue to give us information back. So we ask questions around eating behaviors, what they eat, how they're exercising, how are you sleeping. That will keep coming back into the system. And then the genetic models will change based on that ongoing information. Think about sarcopenia, which is muscle loss. The risk of telling someone about their sarcopenia risk and also knowing what they've done in their life in their 20s is irrelevant. But if you're 50, 60 and 70, we know what your diet's been like. We know what genetic sarcopenia risk is. We know what your training history is like. Then that becomes a very different conversation. So you're buying the product, but actually but the information evolves as we understand your journey through life.
It feels like you can layer in so many different inputs beyond just genetic, your genetic profile, to give a more holistic picture of someone's disease risk. And I guess everyone's sort of doing their own part, but it just seems like there's an opportunity there.
No, sure, and it's essential that the lifestyle data and the other diagnostic data, so the blood data, is essential. In giving the right advice, because if someone gives us a high LDL reading, we're not going to base it on the genetic prediction. We're going to base it on the high LDL reading, and that. But then knowledge of that atherosclerotic risk will then have other impacts more broadly when you think about if they're interested in, so for example, if they've got high diabetic risk within the system, that is important for dementia risk as well. So it's actually then the interplay with those components within the system that need to crosstalk with each other. And that's why it's an ongoing process. So we've been around for 11 years. We've got customers that have been with us for 8 years and still coming back. And we constantly update and release new information, which is not behind a paywall, because that is what science is. It is the constant reevaluation, the providing of new information. Like, for example, one week a supplement may be banded as the greatest solution to a problem. Next week it's killing you. So it's keeping on top of that information as well, which is really important. And you do have to offer that service, I believe, to customers in the long term.
So going back to your insights.
Yes, did you like the way I avoided that? So for me, I'm reasonably burdened on weight gain, which makes a lot of sense to me. I am always hungry. Luckily, which makes sense in my family history, low on heart health risk. There's minimum heart health risk. I've got ApoE carrier status in parts of my family. Again, I'm very fortunate that I'm not a carrier. So it's like everything. There's good and bad's not the wrong one. There's things to concentrate on, and there's things to be thankful for. I guess the way I look at it. I think that's the way I can evaluate it.
Has it influenced your supplement stack, or do you tend to take supplements, or
I'm not a big supplement taker. Like vitamin D is something I take. Creatine is the one thing I've gone to.
Okay.
I think creatine is something I take a lot.
Is that from an exercise benefit or from a brain?
Exercise benefit with a look towards the brain health, actually, for sure. I'm evaluating taurine and L-carnitine.
Okay.
And what that means more just from a scientific point of view, but I think it's quite interesting. I've looked at a lot of these anti-aging compounds like spermidine and all these other things, and I look at them with interest, but I think that's just because I want to live longer, not because or not because there's actually the science is there yet, sort of thing. So it's for me, I eat a lot healthier. Like I'm all non-processed foods now. Lots of salad. My biggest vice will be a nice couple of beers and a nice glass of wine. And again, it's back to trade-offs. There's not just trade-offs in biology, but it's trade-offs in your lifestyle. Some things are keepers, unfortunately. So I am of a personality where I struggle to stick to something for long periods of time, but it gives me the framework to just to give myself a bit of a kick up the butt. To say, you're not getting any younger. There are considerations, and of course, because of my ability to, I probably yo-yo diet, not yo, sorry, I will put weight on particularly certain times of year in winter where I will go through phases of not exercising too much and feeling it's winter, therefore I can eat a bit more, as it were, and it just gives me an understanding that when I'm feeling hungry, particularly at the times when I've been overeating, because again there is that, the more weight you put on, the more leptin resistance that can happen, to be very mindful that when I'm hungry, I'm not hungry. And that's so I've taken quite a bit from the weight loss, weight gain components of our modeling. Less so much on the cardiovascular stuff, just because the burden doesn't seem to be there in both looking at my family and also in the data I'm looking through. And unfortunately, I have skipped a lot of the variants associated with dementia. Unfortunately, for the members of my family, that's not the case. So yeah, I guess that's kind of how I've used it. And the one great thing is we keep adding more and more data to our system, so there'll be new traits, new evaluations. So you'll find new things all the time, and that's one of the great things about doing the research. But the one thing we're actually, and I say we've been doing it at the moment, we've been doing this for 3 years. So at the moment, I think there's 180 traits that sits within the fitness gene suite. And if you're invested in your health, that's great because there's a lot of reading to do. But actually what you need to start doing now is actually understanding the relationship between all those different traits. So we've got a beta system coming out soon where instead of going, can you tell me your 23 cardiovascular traits? Can you show me your, I'm probably about 30 weight loss traits? Actually, you can go in at the top and actually prioritize. So with all the different risk components and preference components in the system, you can go, actually, these are the things you really need to start concentrating on. These, the genetic variants, because as we talked about, you've got the rare variants, which are more penetrant. You've got the polygenetic risk scores that are probabilistic, and then the information ones. As you can go into a lot of these sites, go, well, they all seem much of a muchness. You need to build a system that actually ranks them and prioritizes them to say, polygenetic risk, you know what, this is something you should focus on. There's a chance that you have increased risk going forward, or guys, you need to look at this right now. And the second component of what we do now is, because the guys, we need to look at this right now, will require professional help. So we were classically a direct-to-consumer company, but actually now what we have is a portal where clinicians, where doctors can actually take the information, so it doesn't go directly to the customer, but they can actually take it through their clinics, and they can use it to give clinical advice, and you can triage it. So we've been talking about workout information that can go to PTs, all the nutritional stuff. So the things around what nutritional advice to give to someone with higher cardiovascular disease risk or high dementia risk. Well, that information can go to a nutritionist, or for example, the nitty gritty stuff. And we don't do the cancer biology, all those components at the moment, but in theory, that information could be put through then to go through to clinics where they can actually start looking at the information. And if required, the genetic counselors can be involved. So it's using what is eventually our calculation engine to then assess someone's health holistically, but then to send them to the right places.
Yeah.
Because there's a lot of conversation about AI. I think what was my favorite quote? But obviously, you probably hear this investment as well. Everyone talks about AI, and I think it was someone in the government that said it, some along the lines of AI in healthcare is like teenage sex. Everyone's talking about it. Only a few people are doing it, and the few people that are doing it very badly.
That's such a good one. Who came up with that?
I heard it at like a conference or something a few weeks ago. It was obviously the room enjoyed it very much. And it's not to say in terms of the diagnostics, AI is not important, like with identifying lesions or cancer very early on. I think in more fields, the eye hospital has a great AI sort of process where they can look up for all the different abnormalities in the eye. So we've got all this sort of metadata going on, and we're going to be replacing doctors soon and everything else. But no, again, going back to the ApoE conversation, it's about communication. It's about people. It's about that interaction. So it's great to give someone a technical, a digital tool, but actually I think where this really will have its advantage is through the individuals in the health ecosystem. And I think that's I think that's something we're quite strongly passionate about.
Yeah, definitely. I mean, if I just think about like my impression of this field, I certainly over-index on more information, and I think data and being data centric is something people need to be more inclined to do. And I think we were chatting before about how people right now are perhaps problem unaware, and things like DNA information, for example, makes them problem aware.
Yeah, for sure.
And then it's a case of, okay, now you're problem aware. Can we make you motivated to do something about it? And then once you're motivated to do something about it, you've started some changes. How can we introduce that consistency part?
Yeah, for sure.
So bringing them along that journey from problem unaware to aware is something that DNA sequencing can certainly do. That may even, in and of itself, provide some motivation to do something about the problem. The consistency piece, I think, is something that everyone's trying to figure out.
I think it's a big, because you can build, hypothetically, you can build the greatest biological model that predicts the future.
Yeah.
But if, say, for example, you can have some, just for argument's sake, there's the same condition, you know, two people are identical biologically, so the advice is exactly the same. But if you then compare, I don't know, an upper middle class woman in the city of London versus a young Bangladeshi lad in Birmingham, the way you communicate it, the way that the foods that they're exposed to, the educational level they're exposed to, all these different parameters, getting those local solutions is essential. Yeah, because you've got to make it relevant to them. You have to make it relevant to them. And we in science strive to have better predictability and everything else, and sometimes we have too much arrogance and we forget the very personal components that the you know, someone might like mum's cooking, or there's traditions in the family, or people just don't like things, or people are embarrassed to go to the gym, and it's those bits are actually like potentially the biggest hurdles, not the fact that we can keep throwing data and building better models and predicting the health risks. It's how do we intersect the nerds with the people with communication skills. I think ultimately, and I think that's where the success in healthcare, I think, will arise from. The preventative healthcare.
Absolutely. Stuart, this has been super enlightening. I really hope people have found this useful. I've certainly found it useful, and I've got a much clearer picture of the state of play and just how impactful this technology can be, this data can be, in combination with all the other things that you've spoken about. So appreciate your time.
Thanks for the invite. It's been great. Enjoyed it. Thank you.
If you want to lower your risk of dementia, I've done a video right here that's all about food swaps that you can action today that will massively lower your risk of dementia. Check it out right there.